am Carrie Sundra, and this is my final project for Making Embedded Systems class taught by Alicia White. If you're watching this and you want to be a better programmer, you should totally take this class. It's amazing. All right, so for my final project, what I wanted to do, I created something called the palLED, P-A-L-L-E-D. It's kind of like an LED pal as well as an LED palette that helps you understand how RGB values translate to actual color in the LEDs. And here, I will show it to you now. This is, of course it is a proof of concept. So it is a bunch of spaghetti wires. What we see here, I'll just describe the physical hardware, then tell you what it does. So we have 3 encoders here. They're rotary encoders. So they have 2 channels that basically switch from high and low as they go around. They basically are little switches internally. So it's kind of cool how they work. Then I have a normal rotary potentiometer right here, and that's for controlling brightness of the LEDs, as you can see here. All right. And there's obviously an LED matrix as well as an LED ring. It is entirely powered by the Raspberry Pi Pico, the RP2040. And there is actually a second RP2040 underneath me right here that is working as the Pico Probe debugger, which I haven't used a whole lot, but I'm glad I have it. I've been using, in terms of software and stuff, I've been using VS Code with Platform.io and a third-party platform called Wizio, W-I-Z-I-O. And it allows you to use the straight Raspberry Pi SDK without having the Arduino layer on top. Okay, so what does it do? Basically, it controls colors on these 2 WS2812 LED strips, so they're standard addressable LEDs. And my idea was that I wanted to have one ring of LEDs that kind of served as your color wheel, so that you could see where the color on the matrix was, where your active color is that you're kind of manipulating and changing, like how that translates to color on a color wheel. And I want to have eventually several different modes that shows you the complementary color of your active color, the split complementary, adjacent colors, allows you to change those things and change parameters about those things and create your own LED color schemes. And it would also tell you what every single LED value is out of the serial port, or also give you basically like the instructions on how to create those LED colors yourself, in code. Yeah, I've learned a ton about color spaces and stuff, but let me do the demonstration first. So it's very, very basic right now. Of course, time being limited, I didn't implement too much. Here is a little bit of a demo of the modes, and I'm going to go to computer view here so that you can see the output of the serial terminal that is down here. Oh, my cursor is not capturing anymore for some reason, whatever. Anyway, so basically in the mode that it starts out in is basically one type of RGB color picker mode, and it's showing you here where the color is on the color wheel. Red is at the very bottom here, and it starts off with red at full blast, but the brightness is down, so you're not seeing it at full blast. Like that would basically be full blast. And so we're gonna turn it down here so we can hopefully get a good video. And now if I move the red around, you can see that the red value is adjusting. You can't really see, it's like such a small difference in brightness that you can't really see it visually, and especially not on a camera, but you can see when it wraps over from 255 to 0, it goes out. And so what's really interesting in this mode, my red, green, and blue encoders actually control red, green, and blue values. So if I put green on at full blast as well, we get actually kind of like this yellowy color, and you can see that my LED on the color wheel changed to the yellow position. And then similarly, if we do blue at full blast, we'll get sort of a purpley color, and my LED shifted to the purple position on the color wheel. And if I turn red off, now we're full blue. And now if I turn green on, now we're at cyan. And then if I turn blue off, we're at full green. And then if I turn red on again, we're at yellow. And then if I turn green off again, we're at red. So you can kind of see how it goes around the color wheel. But honestly, it is not very intuitive to do it this way. Like, you know, you dial colors and it kind of changes, sometimes in ways you predict, sometimes in ways you don't. You start to get all three in and things just go white, and like your little LED just sort of like jumps all around the color wheel, just depending upon like what your values are, you know? So it's, turn the brightness up on that a little bit. So while it allows you to very specifically dial in RGB values for an LED, like it's not very intuitive about how to go from one color to another. So that's where this other mode comes in. And I have not gotten, there's some issues with brightness. Brightness kind of, it interacts in ways that are not necessarily intuitive, and so I'm kind of working on that. So we're going to put this back to red. And now I'm going to put it in the second mode, which I do by pressing the button on the encoder here. And there's like a little bit of a blink to give you some visual feedback on like, yes, I have switched modes now. And now I'm in this sort of wheel-based color picker mode where when I turn the encoder, the color will rotate around the color wheel. And so now you can see it's like much more intuitive. It's like, oh, okay, I'm changing it around the wheel. I'm going from red to green to blue. Now I'll be going towards purple here. And it's much easier to kind of intuitively understand and to just also see your progress around the color wheel. Oop, other way. So this one I think is like a little bit more useful but less exact. So eventually, like, so the last state that I have right now is a complementary color state. So this is showing you right now kind of a standard. It's actually showing you an RYB color wheel, and I'll talk more about color spaces and stuff in a second. But it's just showing you your main color and the complementary color on the LCD there. So our main color is sort of like this pinky color, and then that blue is the complement in RGB color space. So as I said, I learned a ton about color spaces, and wow, there was a lot I didn't know. First of all, in order to understand like what angle and what LED should be lit around the color wheel, I had to transform RGB values into hues, saturation, and luminance values. And what's cool is that hue is essentially the angle of the color around the color wheel. So that made it real easy, but there are also kind of two different color wheels. There's an RGB color wheel and there's an RYB color wheel. So we have red, green, blue versus red, yellow, blue. And RGB, of course, is used with light because those are the three colors of light that all add up to make white, and then the absence of all of them makes, you know, a dark color, right? Black. So, but what we're taught in school is we're sort of taught the paint color wheel, which is like a different color scheme entirely. It's based on red, yellow, and blue, and the combination of those primary colors gives you all the secondary colors. All of them together make black. The absence of all of them is white. So it's kind of the reverse, One is an additive color scheme, the other is a subtractive color scheme. However, when we're designing colors and like when graphic designers are designing colors and stuff, and when we're thinking about colors in terms of like being pleasing to look at and working together and giving pops of contrast, we tend to think in this RYB color space. And what I eventually want to do is show you in this RYB color space what the complements are and the split complements and things like that, but also convert that to RGB values that you can then display on your LEDs. I have no idea how useful this is for people, but I find it fascinating. So yeah, there was a lot more color transformation between like RGB wheels, RYB wheels, hue saturation luminance to RGB, and I'm still working on stuff. I just read about an HSV color space, which is a little bit better for LEDs because it works with like kind of shades of darkness instead of shades of lightness. And yeah, it's really fascinating. I'm learning a ton, and eventually I would like this to be a tool for people to understand more about this stuff as well. One more thing before I stop this video and shut it off. So I've implemented like a couple of commands in the serial console, but basically the print command. Really? Command not found? What? There we go. The first one has junk in it for whatever reason. I haven't quite figured that out. So the print command basically gives you a ton of information about the colors that are being displayed. So first we have the ring data. So these are all the colors that are being displayed on the ring. And there's a little bit of sort of debug data in here as well as I was going, but it was very helpful to be able to test my my conversion algorithms. So these are our for the color wheel, these are the kind of native RGB values for each of the LEDs in the color wheel. These are them corrected for the brightness setting that the knob is at. And then we have the hue, saturation, luminance values, and then we actually convert them back to RGB from the hue, saturation, and luminance in order to make sure that everything is working right. And then we also calculate where these would be around the color wheel. This was a hand-generated, these were hand-generated by me to look pleasing to the eye, and so they don't correspond, the calculations don't actually correspond with the LED number, but yeah, that's just because I'm displaying like a fixed color wheel in this particular mode. In other modes, it'll show you like which of the LEDs is actually active. For the matrix, I'm doing the same sort of thing for the matrix, although I'm not calculating any LED numbers for that. But again, you're getting the whole transformation of what each LED is, as well as hue, saturation, luminance. And then back to RGB for like a sanity check. That's pretty much it. I'm excited to do more about this. I know it doesn't look like too terribly much right now, but once I get some of the other color schemes going, I think it'll be really cool. And once I get the color space transformations a little bit better, I think it'll be pretty interesting. So there you go. I hope you liked the palLED. How do I stop this thing?